Welcome back, physics fans. Let's just continue on from beforehand. We have this worksheet that started off our work package. And, oh, OneNote's not loading. Let's just pause. Let's start it off with our first lesson going over all the terms and Newton's three laws. And the terms are to be filled in here. Please fill them in, the 24 terms. Put them down. We also did over this homework of page 70 to 75, went over a few questions there, and then assigned 7 questions here from page 76A all the way and 117. We've gone over them. I asked you to read stuff on frictional forces, and let's just go over a couple questions there. And then if you have more questions, just email me and I can make another video if you're having issues. We'll do number 2, and we'll actually calculate the force on a wet road, the skidding. Now you're sliding, this is the kinetic. So these are locking brakes, not anti-locking brakes. So calculate the driver of a car that's 1,500 kilograms puts on the brakes and skids with locked tires on a concrete road. Calculate the force of friction on an icy road. So it's mu times n, and there's my free body diagram. You're moving this way, but you're accelerating that way. You're slowing down to a stop. The only force that's in that direction of acceleration is the force of friction. So mu mg, mu is 0.15. The mass is 1,500 kilograms. And we're on Earth, 9.8 newtons per kilogram. So 0.15 times 1,500 times 9.8, 2205. 2205 newtons. Now I said that's the only force acting in the direction. I'm going to ruin my free body diagram. That's the direction of motion. The other two have to balance, and that's the direction of the acceleration of the net force. So it's just the force of friction that's causing the net force, which is equal to ma. Get rid of that. I don't want to have a ruined free body diagram on there. So 2205 is equal to the mass, 1,500, times the acceleration. So take this and divide it by 1,500, and you get the acceleration is 1.47 meters per second squared. That's actually a deceleration. We know that. It's in the opposite direction of motion. The initial speed in number 3 is at 54 kilometers an hour. And 54 divided by 3.6 is 15 meters per second. So this way, and it's that way. The final speed is 0. So we just have to calculate the stopping distance. This is part of number 3. And the stopping distance, how do we calculate that with these 3 givens without time? Will be Vf squared is equal to Vi squared plus 2AD. That'll be 0 is equal to 15 squared plus 2 times A, which is 1.47, and D. Now this will be a negative because it's in the opposite the direction of motion. Okay, so this is going to be 225. 0 equals 225 plus 2 times that will be 2.94D, and it'll be negative. Take the over that, it'll be negative. And then we divide by a negative, so D is going to equal negative 225 divided by a negative 2.94. So 225 divided by that number, and also divided by 2. So the stopping distance on ice is 76.53 meters. So you'll have to do it for all the other ones and see if you can get all those answers for the stopping distances. Okay, and let's scroll down. This talks about static friction and the difference, and that it's with a less than or equal. Please watch a video. Which video do I want you to watch? It's a second video that I'm getting you to watch for sure. Okay, there's the first one. That was yesterday's lesson. Now we're watching this one that I'm teaching you. But I want you to watch that video from Khan Academy, and all his examples are fabulous. Okay, and all these ones on ABS will understand why we have anti-lock brakes and how they work. And now here's anti-lock brakes. So they're now static. Use static. Before we used 0.15, now it's from 0.3 to 0.4. And do number 6. Okay. And we'll wait to do this one in a moment. So get those questions done. And we'll do this one when the weight ain't normal anymore. Subscribe, check often, please. Check your emails. Smash the like button. Leave your comments below or to the side or above or behind. Anyhow, glad that you're with me. Thank you. Bye-bye.